So members, in this problem, we are looking at a ladder problem, and this ladder problem, we are still looking at applications of friction. And the guiding question says, a uniform ladder of length 3.25 meters and weighing 250 newtons is placed against a smooth wall, a smooth vertical wall with its lower end 1.25 meters from the wall. The coefficient of friction between the ladder and the floor is 0.3. So we are told that the coefficient of friction between the ladder and the floor, mu F, is 0.3. What is the frictional force acting on the ladder at the point of contact between the ladder and the floor? So we are looking at FF. Show that the ladder will remain in equilibrium in this position. So if we are going to, for example, use this ladder, if we consider all the three cases of static equilibrium, the sum of forces in the vertical direction equal to 0, sum of forces in the horizontal direction equal to 0, and sum of moments about a point equal to 0, if we explore all these conditions, we will find that we are getting different values of FF. So if the maximum value of friction at the point of, for example, at the point of contact with the floor is greater than the force when we take moments, okay, we will find that if that force is greater than the one that we shall get when we take moments, then that ladder will remain in equilibrium. It will not move because this ladder moves in times of friction. The ladder will move, or any body that is under friction will always move when the maximum limiting force or the maximum or the static limiting friction value is exceeded. So the moment it is exceeded, then you have an issue to deal with the equilibrium. In other words, there will be motion at that point. So what do? Let's right away indicate this information, the scenario. Our W is given as 250 newtons. That's the weight. Then the ladder is of uniform length, 3.25. So from here, the length of the ladder is 3.25 meters. What else? We are told that it is weighing 250 newtons placed against a smooth wall with its lower end. Okay, the lower end is 1.25 from the wall. So from here, okay, from this lower end, the lower end of this, let me see. So the lower end is 1.25 meters from the wall. So this point here, they are telling us that from here to here, okay, is 1.25 meters from the wall. This lower end of the ladder is 1.25 meters from the wall. So what does it call us to calculate? This one, we are told that this is 3.25 meters. So for that matter, we can get this angle. So what is cos alpha? Cos alpha is 1.25 divided by 3.25. So I'm going to get cos cosine arc of 1.25, we divide it by 3.25. So alpha is equal to cos arc of 1.25 divided by 3.25, and alpha is equal to 67.38 degrees. So that is one. So we are told again that the coefficient of friction between the wall and the ladder is 0.3, and the vertical wall is smooth. So if it is smooth, if this wall is smooth, again, let us say wall is smooth. If the wall is smooth, then nu W is equal to 0. That is the coefficient of friction between the wall and the ladder. Therefore, if that one is the case, then Fw is also equal to 0. So what force is going to be acting is going to be the reaction Rw. We will have Ff, we will have Rf, and the weight of this body, or the weight of the ladder. Therefore, we are going to look at sum of forces in the vertical direction. So sum of forces in the vertical direction, let us consider forces forces that are facing upwards to be positive, and those facing downwards to be negative. Therefore, Rf minus 250 must equal to 0. So Rf, let me put it here. Therefore, Rf must equal to 250 newtons. That is one. What else? How do we get Rw? We can get Rw by taking forces, sum of forces in the horizontal direction. So we know that Rw, if we are taking forces in this direction to be positive, okay, let us take them to be negative, so that Rw negative plus Ff positive will equal to 0. Then Ff will equal to Rw. But what is Ff? Okay, Ff is also equal to Ff, okay, has a limiting value. Okay, this is not a limiting value of friction, but since we are told that it has a coefficient of friction, let us use that nu F Rf, because we know friction is equal to nu R. So this is equal to 0.3 times 250. So what is that? This is going to be 75 newtons. And that is going to be our frictional force. Okay? That's the frictional force at the contact, at point of contact between the ladder and the floor. So that is the one. So what is the frictional force acting on the ladder at the point of contact between the ladder and the floor? So that is the one that we have just obtained from considering horizontal forces, some of them being equal to 0. Now let's take moments. Let's take moments about B, because we want to determine the value of frictional force. We want to determine the value of the frictional force when we take moments. So what is the vertical component? The vertical forces, we have 250. That one, the horizontal is Ff. Now, what is the force that is in a clockwise direction? I will say this one is in anti-clockwise direction. This one, the FF, the frictional force, we are prolonging its line of action from the principle of transmissibility. We are going to prolong. So that is FF. And it has a distance of a perpendicular distance that we said this is L sine alpha. Then we have also this distance here, which we said it is going to be L out of 2 cos of alpha, because we said this is alpha. And we know the distance from here to there. Okay, that one is known. So what is L sine alpha? Maybe let's look for it. Okay, let's first get those moments. Let's look for clockwise moments. Clockwise moments. So what are the clockwise moments? This is in anti-clockwise, and the clockwise moments will come from RF. So it is this that is going to give a clockwise moment. So this is going to be a clockwise moment. So what is the perpendicular distance? It will be RF times 1.25. Okay, from here to there. It's the same as from here to there. So it will be RF times 1.25. But this is 250 times 1.25. So 1.25 times 250. The answer that we are getting is 312.5 newtons. Then let's look at anti-clockwise moments. Anti-clockwise moments. The anti-clockwise moments will be composed of the 250 newtons, which is the weight of the body, and the FF, which is the frictional force at the point of contact between the ladder and the floor. So this will be FF times L sine alpha. So this will be FF times L sine alpha. Then plus W times L out of 2 cos alpha, because that's what we said. You remove a distance of L out of 2 cos alpha. So we are looking for FF, so multiply by L sine alpha. So L sine alpha is the same as, we say the L is 3.25. We multiply by sine of 67. The angle is 67.38. So this is 3.25 times times sine of that angle times sine of 67.38, then plus 250 times L out of 2, which is 3.25 out of 2 cos of alpha. So this will be FF times this, which gives us 2.999, okay, plus this is 250 divided by 2 times 3.25 cos of 67.38. So this is FF times 3, because this is approximately or equal to 3, plus we have 250 divided by 2. So I have 125 times 3.25 times cosine of 67.38. So this is 156.25. So remember, this was, I can call it equation 1, equation 2, and say from principle of moments. Then 312.5 should equal to 156.25 plus 3FF. So what will be FF? This will be 312.5 minus 156.25. Okay? We divide by 3. So I have 312.5 subtract 156.25. I'm going to divide this answer by 3. So my answer is 52.08 newtons. So we have two values of FF. Okay, we have a one of 75, which is as a result of this coefficient of friction. Okay, and we have also the force of friction that is obtained from when we apply moments. The moments are going to be applicable when we load this system. So now, when we load this system, we find that the frictional force at the floor here does not go beyond what the coefficient of friction here is providing for. And therefore, this ladder will remain in equilibrium. So FF equal to 52.08 newtons is the frictional force which acts when the ladder is loaded. Now, since it is less than what the coefficient of friction between the floor and the ladder provides for, then the system will be in equilibrium. So we have answered these questions. 1, what is the force acting on the ladder at the point of contact between the ladder and the floor? We have calculated it. Then show that the ladder will remain in equilibrium in this position. So the calculated value that we had in the beginning was as a result of applying the static conditions of nu F, RF, okay? And at that point of the contact, that value is equal to 75 because the coefficient of friction is 0.3 and the RF is 250 newtons. So we have 75 newtons. Now, we are saying if we take moments, we shall find for F. If we calculate for F and we find that it is a different value, it is either going to be higher or less. But since this friction force that we are obtaining from moments is actually the force that is acting when this ladder is loaded, in other words, when it is working, so as long as this frictional force does not go beyond the frictional force which is provided for by the coefficient of friction, then this ladder system will be in equilibrium.